baby. Right, can we start now? What are you talking about, man? Can we start? Where's your pen and paper?
What?
Hey, where's Lee?
I don't know. He's already late.
Okay. Bruce, we're looking at vectors. What's vectors?
I don't know what about.
You know this, Bruce.
Victory. No.
Vic, what?
Victory.
Weird. Euclidian. Okay, so what we have now is a small problem, because last time we were looking at vectors, and how do we represent vectors from last time?
Rule.
Yeah, but how do we draw them? We just draw them by making
Move them.
arrows. Yeah, but this isn't really accurate. This is a problem that you notice. So another way we can make vectors is we can use points. So for example, if I have a square like this, A, B, C, and D, I can actually make many vectors using this point. So for example, this vector here, I can call that vector the AB vector, and I put a little arrow on the top. And that means the vector you get when you draw an arrow from A to B. But you realize this gives me a chance to make many vectors. So I could make AB, AC, AD. But not only that, I have BC, BD, BC. You know, I have lots of possibilities. So in other words, this here, we say, is the vector with a tail at point A and a head at point B. Yeah? Okay, so if you can write that definition down for what the vector is. And I call this a Euclidean vector.
Yeah, what's that mean? What's Euclid?
Euclidean is named after Euclid. Euclid was a mathematician from about 2,000 years ago.
How famous he actually like?
Because he wrote one of the most important maths books ever, called Elements. And it was a geometry maths book, and it was the most important maths book that everybody used when they were learning maths for about 1,600 years, until Newton, and then calculus was invented, and then these books became more important. But before the year 1600, everybody who studied maths, like, there was only this maths book, because that's all the only thing maths was geometry, you know, like shapes and triangles and things. So all the knowledge of maths was just in this one book, and it was the only maths book for, you know, about 2,000 years.
Who's that? What math line?
That goes back a long while, caveman perhaps. Okay, continue. Yeah. So let's see how we can use this. So we'll go back to the square example. Can I scroll down? So let's imagine we have a square. A, and we'll put the B here this time. C, D, and this is a square. And let's also, dude, why are you late? You live here. Let's put a point here in the middle. I'll call this point here M. Okay, so let's see. My question is, write these vectors in terms of AB and AD. So let's start. Let's start with something like vector AC as our first example. So I want you to write this vector using only AB, AD. So if you look at vector AC, here it is here. You could say it equals, yeah, AB
plus AD.
plus AC, yeah. But then you would have to change one of them. Because AB is actually the same as DC. Hang on, there's AB and...
AD.
Oh no, sorry, AB is fine. I want AB. Yeah, it's BC that's the problem. But you can see that BC is the same vector as AD. So you can actually change that into AD then. Okay, second one. Let's say BM. BM. Well, you could say BM, if you look at it, is a half of what vector? BC. But BC is the same as what vector? AD. And so we've written BM as an AD vector. We see where this is going? Let me give you one to try. Try this one, MD. Try this one for me. MD. Yeah, MD we can say is MC plus CD. But MC is a half BC, yeah. And BC is the same as AD. So we still need to do something about the CD here. But we can see that CD is kind of like AB. Yeah, I said it's kind of like AB, except what's the difference between CD and AB? Yeah, it's the same vector except opposite direction. So we can write that as minus AB.
Okay, we write like plus.
Or plus minus. No, because I specifically said I wanted AB and not BA. Yeah. Yeah? Okay. Try this one for me.
Steven,
Yes.
can I say half AD and plus EA?
You just asked me that exact question. Isn't that exactly what you asked me? You asked me why can't I use BA? And what did I say?
Because we AB and AD.
Now you see, you were making fun of him earlier, and you just did the same thing. All right. Try this one now. MA. Yeah, try this one.
MA.
Yeah. think you got this one?
Okay.
So MA will be MB plus BA. Now MB is a half CB, and BA is minus AB, it's just the opposite direction. And CB is DA, or in other words, minus AD. Yeah, okay. We getting the idea? Alright, let's try a harder one.
Teacher,
Yeah.
do you have to write it like step by step, like MBA?
No, if you can jump straight to the answer, that's okay. I'm just showing the process. But let's look at another one now. Let's call this A, B, C, D.
No, this is not like Ben 10.
Yeah, green light.
That's great, guys. That's great. I'll also tell you that the distance from A to C is twice the distance from C to D. I know it doesn't look it in the picture, but A to C compared to C to D is equal to 2 to 1. This is twice as big as that. Alright? So, using, let's see, we'll say AB and, what's wrong? What do you mean?
This is opposite.
AC to CD is 2 to 1. I'm saying this is twice as big.
Because sometimes confusing, we have two type of ratio. Like sometimes one is the one the bigger, sometimes one is the one smaller.
One AC is 2 one AC is 2 CDs, yeah.
CD is
Oh.
1, AC is 2.
Yeah, yeah. Using
CD is 3.
what do I want? Okay, no, actually, let me just give some different questions here. So, first question is find AC in terms of AD. Yeah? So what is that for the first answer? 2 over 3 AD. Very good. Okay. Now, let's see. The next one, let me just tell you, this piece will say, and this piece here, will say this one is 4 times bigger compared to that. 4 times bigger. So now my next question is going to be pretty similar. Find BC in terms of BE. Got that?
Yes.
What did you get here?
4 over 5.
4 over 5
D.
BE. Okay. Now, let's see. Another one. Part 3. What was the first one I did? AC. Wasn't it? BC. Okay.
AE.
Well, I'm thinking... ED. Find ED.
Sharon.
What?
Something there, you stop that from first to
What's he
here.
talking about?
I mean, when you do DM, he say BMW, and he keeps saying that near
Well,
me.
what's ED?
I just woke up.
Ed Sheeran. He say Ed Sheeran.
Loser.
What?
You like Ed Sheeran?
Yeah, why not? Like, what if?
No, I kind of thought so. It's always the strange ones.
You don't like Ed Sheeran?
He's alright.
Like, who doesn't?
He's alright. Okay, find ED.
Damn, but Ed, that's nice one.
Yeah, we know.
Find ED in terms of.
So, A, B, C, D.
ABCD.
Now you're confusing me. What do I want? I don't make it too hard for you.
A, D, and B.
into BD as we can get AB.
A, D, and B.
Oh, you're so smart. ED. Oh, AB.
We can use A, D, and B to H.
Please stop. Find ED in terms of AD and BE.
AB.
Yeah.
AB.
That's too easy.
AB.
Fine, if it's too easy, it's too easy. Fine, I don't care. Find it in terms of AD and BE. Yeah? Okay, so ED, I think I'll say ED equals EC plus CD. Okay, now EC, I can see that's 1/5 EB, isn't it?
Yeah.
Yeah.
Huh? Yeah, well I'm doing it bit by bit, yeah. EB, and then plus, and then the CD is 1/3 AD, isn't it? Now that's fine, but what's the problem with this one? Yeah, so EB, I really want to use BE, but the only difference is it's backwards. So I will have minus 1/5 EB plus 1/3 AD. Oh, goodness. So you distracted me now with your Ed Sheeran stuff. 1/3 AD. Okay, I think that one wasn't too difficult, was it? I don't need to make them too hard because it's kind of like what we're doing. Yeah, that's plenty of examples. So you can see in the workbook there's only 5 questions. They're all pretty easy. So you should be able to get 5 of them done now. It gets a little bit harder from number 3 onwards. 1 and 2 are very easy because it's just a square. But in number 3, what shape is that? Number 3? Hexagon. Now it's useful to know, do you see all those circles?
Mm-hmm.
They all mean that it's the same angle. So in fact, you can know what angle that must be. Well, it has to be 60. So all those angles in the hexagon are 60 degrees. They have to be, because look in the middle. The middle, how many angles are there in the middle? 6, and what should the total be? 360, so they have to be 60. And each of these is an equilateral triangle, so the 3 angles have to be the same. So like it works out quite nicely that every single angle is 60 degrees. Makes it quite nice. Okay, can you try these for a few minutes, and then what's our next lesson? Position vectors, is it? Yeah, position vectors.